Welcome. Today we want to look at this question on the roots of quadratic equation. Given that alpha plus 1 and beta plus 1 are the roots of the quadratic equation 2x squared minus nx plus n is equal to 0, where n is a constant. Find in terms of n the quadratic equation whose roots are alpha squared and beta squared. Our quadratic equation again, the given quadratic equation is 2x squared minus nx plus n equals 0. All right. Now, from here we know when we compare with our classic or standard quadratic equation, ax squared plus bx plus c equals 0, we see that a is 2, b is negative n, and c is n. Okay. Now, we are told that the roots are alpha plus 1 and beta plus 1. Okay, and we know the relation between the sum of roots and the coefficient of the quadratic equation. Sum of roots, we know sum of root is negative b all over a. And so this is negative, our b is negative n all over a. Now that gives us n all over 2, sum of roots. So let's carry out now the sum. Remember, these are the roots. So we carry out the sum. So we're saying alpha plus 1 plus beta plus 1 should give us n all over 2. Alpha plus beta, 1 plus 1 is 2, is equal to n all over 2. So from here we can have an expression for alpha plus beta. There's a reason for that. I will explain later. So from here, alpha plus beta will be equal to n all over 2 minus 2. All right? This will be necessary. We'll need this expression when working out the new quadratic equation with roots alpha squared and beta squared. This expression will be necessary. We'll need it. That is it for sum of roots. What about product of roots? Product of roots is c all over a, and we know our c is n, and our a is 2. All right, so let's carry out the product. That means this root multiplied to that root. And so we have alpha plus 1 multiplied to beta plus 1. Now what do we have? Alpha multiplied to beta is going to give us alpha beta. Alpha multiplied to 1 is going to give us alpha. 1 multiplied to beta is going to give us beta. 1 multiplied to 1 gives us 1. Okay, so we expect this to be n all over 2. So this means alpha beta plus alpha plus beta. We already have an expression for alpha plus beta. It is n all over 2 minus 2. So plus n all over 2 minus 2 plus 1 gives us n all over 2. Okay. All right. So from here, we can come up with the expression for alpha beta. We also need an expression for alpha beta, just like that for alpha plus beta. So okay. So let's write this again up there so that we follow up. We have alpha beta plus n all over 2 minus 2 plus 1 is equal to n all over 2. Okay? We want to get alpha beta. We want to have an expression for alpha beta. It simply means we carry every other thing that way. So we have n all over 2, this one. Then all of these other ones, since they are all plus plus, they become minus. So it becomes minus n all over 2 minus 2 minus 1. And we'll carry all of this to the right hand side. Alright, so let's open the bracket. So it is n all over 2 minus n all over 2 minus minus become plus 2 minus 1. So this gives us n all over 2 minus n all over 2 is 0. So we have 2 minus 1, which is 1. Alright, so it gives us 1. So we are saying alpha beta is 1. This is also going to be needed when we'll be doing the second part of the question. Now we have an expression for alpha plus beta in terms of n, and we also have an expression for alpha beta. All right? Now, maybe we should write those two down here. So we have alpha beta is 1. All right. Now, new roots. New roots. Alpha squared and beta squared. Okay? New roots alpha squared and beta squared. We need to know an expression for sum of new roots. Sum of new roots. That means we add up the two new roots. But alpha squared plus beta squared is the same as alpha plus beta minus 2 alpha beta. Okay? Why have we chosen to write it as such? Because we have an expression for alpha plus beta, and we also have an expression for alpha beta. So we prefer to write like that in order to come up with our quadratic equation in terms of n as the question demands. So this will be, we know alpha plus beta is n all over 2. Pay attention, sorry. Alpha squared plus beta squared is alpha plus beta all squared minus 2 alpha beta. Okay, we should be very careful not to miss out on any important aspect of these expressions. So we know alpha plus beta. So it is n all over 2 minus 2 all squared. So we have n all over 2 minus 2 all squared minus 2 alpha beta. Alpha beta is 1. Now, what is n all over 2 squared? Let's do it here. N all over 2 minus 2. Sorry, what is n all over 2 minus 2 all squared? It is n all over 2 minus 2 multiplied to n all over 2 minus 2. All right? N all over 2 multiplied to n all over 2 is n squared all over 4. N all over 2 multiplied to negative 2 is going to give us negative n. Negative 2 multiplied to n all over 2 is going to give us negative n. And then negative 2 multiplied to negative 2 is going to give us plus 4. So that we have n squared all over 4 minus 2n plus 4. Okay? Now, let us carry this and put it here. So that we'll have alpha squared plus beta squared to be equal to, in the place of this, we're going to write this. We have n squared all over 4 minus 2n plus 4 for this. All right? And then minus 2. Okay? Okay. So this gives us n squared all over 4 minus 2n. 4 minus 2 is 2. Okay. So that is it for sum of new roots. That's it for sum of new roots. Now, what about product of new roots? Product of new roots means we take the product of the two new roots. Alpha squared multiplied to beta squared is the same as alpha beta all squared. But we know that alpha beta is 1. So we have 1 squared, which is 1. Okay, so we know the sum of new root and product of new roots. So what is the new equation now? New equation. New equation has the form x squared minus sum of new roots times x plus product of new roots equals 0. Okay, so so this gives us a new equation. It gives us x squared minus sum of new roots, which is n squared over 4 minus 2n plus 2x plus product of new roots equals 0. Now let's open out this bracket because all of these things multiply to x. So we have x squared minus n squared all over 4x minus minus become plus 2nx minus plus become negative 2x plus 1 is equal to 0. Now to do away with this denominator, we don't want to work with fractions like this. We don't want a denominator. Since the other ones, their denominators are 1, we can write all of this as all over 1, all over 1, all over 1, all over 1. The LCM of 1 and 4 is 4. So we're going to multiply all through by that LCM. The LCM is 4. So we're going to multiply all through by 4. All right, so we'll multiply each term in this expression by 4. That's going to give us 4 into x squared minus 4 into n squared all over 4x plus 4 into 2nx. All right, minus 4 into 2x plus 4 equals 0. Plus 4 equals 0. Okay, plus 4 equals 0. So 4x squared is going to have 4x squared. This 4 cancels here. You have minus n squared x. All right, 4 multiplied to 2, n gives us 8nx. And then negative 4 multiplied to 2x gives us negative 8x. Then plus 4 equals 0. Remember, it is a quadratic we are forming here, a quadratic in terms of x. So let us arrange everything in terms of the powers of x in decreasing order. So we have here x squared. There's no other x squared. So we have 4x squared. Now we take the x term. We have x, x, x. All right. So we say plus, all right, x into, here we have negative n squared. Here we have plus 8n. Here we have negative 8. All right. Then plus 4 is equal to 0. Okay. So far, so good. So we have arrived at a new quadratic expression in terms of x and n. You know, a quadratic equation has its variable. The variable is x, but the expression here is given in terms of n because the equation says find in terms of n the quadratic equation whose roots are alpha squared and beta squared. So this should be the required quadratic equation in terms of n. 4x squared plus x into negative n squared plus 8n minus 8 plus 4 equals to 0.